Look up at the night sky, what do you see? The vast expanse above us is dotted with countless points of light. Countless stars twinkle back at us, each one a beacon of light in the darkness. Each one is a distant sun, burning brightly across the vastness of space. These stars are not just points of light, they are massive, powerful entities. Their light has traveled for thousands, even millions of years to reach our eyes. Imagine the journey of a single photon, traveling across the cosmos to be seen by us. But have you ever wondered where these stars come from? How do they come into existence in the first place? How are they born, and what happens to them when they die? The life of a star is a cycle of birth, evolution, and death. The life cycle of a star is a story of incredible power and transformation. From their fiery births to their dramatic deaths, stars undergo a series of changes. It's a story that unfolds over billions of years. A cosmic tale written in the fabric of the universe. It's a story that's essential to understanding our place in the universe. By studying stars, we learn about the origins of the elements that make up everything around us. The universe wasn't always filled with stars. In the beginning, it was a very different place. In its earliest moments, it was a hot, dense soup of particles. There were no stars, no galaxies, just a chaotic mix of energy and matter. But over time, gravity began to pull these particles together. Slowly, the universe started to take shape. These clumps of matter grew larger and denser, eventually collapsing under their own weight. This process marked the beginning of star formation. This is where the story of a star begins. From the chaos of the early universe, stars are born, bringing light and life to the cosmos. Their journey is a testament to the power and beauty of the universe. Stars are born in giant clouds of gas and dust called nebulae. These vast regions of space are often referred to as stellar nurseries because they are the cradles where new stars come into existence. Nebulae are scattered throughout the universe, each one a potential birthplace for countless stars. These nebulae are some of the most beautiful and awe-inspiring objects in the universe. Their ethereal beauty captivates astronomers and stargazers alike, with their intricate patterns and vivid colors painting a cosmic masterpiece across the night sky. They glow with vibrant colors, illuminated by the light of nearby stars. The radiation from these stars excites the gas within the nebula, causing it to emit light in a dazzling array of colors, from deep reds to brilliant blues. Deep within these nebulae, gravity draws gas and dust together. Over time, these particles clump together, forming denser regions within the cloud. This process can take millions of years, as the forces of gravity slowly but surely pull the material into tighter and tighter clusters. As more and more material falls inward, the center of the cloud heats up. The increasing pressure and temperature cause the core to become incredibly hot, reaching temperatures of millions of degrees. This process is called gravitational collapse. It is a critical phase in the birth of a star, where the balance between gravity and pressure determines the fate of the forming celestial body. The temperature and pressure at the core continue to rise until something incredible happens. The conditions become extreme enough to trigger nuclear reactions. The hydrogen atoms, squeezed together with unimaginable force, begin to fuse. This fusion process is the same reaction that powers our own sun, converting hydrogen into helium and releasing vast amounts of energy. This process, called nuclear fusion, releases an enormous amount of energy. The energy radiates outward, providing the light and heat that we associate with stars. This energy pushes outward, counteracting the inward pull of gravity. A star is born. This delicate balance between gravity pulling in and energy pushing out is what allows the star to shine steadily for billions of years, lighting up the cosmos and nurturing the planets that may form around it. Once nuclear fusion begins, a star enters what's called the main sequence. This is a critical phase in the life of a star, marking its transition from a young, nascent object to a mature, stable entity. This is the longest stage in a star's life, often lasting billions of years. Our own Sun, a middle-aged star, is currently in its main sequence. It has been in this stage for about 4.6 billion years, and is expected to remain so for another 5 billion years. During this stage, the star exists in a state of equilibrium. This balance is crucial for the star's stability and longevity. The outward pressure from nuclear fusion balances the inward pull of gravity. This delicate balance ensures that the star neither collapses under its own gravity, nor explodes due to excessive internal pressure. The star shines brightly, converting hydrogen to helium in its core and releasing a constant stream of energy. This energy is what we perceive as the star's light and heat. The length of a star's main sequence lifetime depends on its mass. More massive stars have shorter lifespans, while smaller stars can last for much longer periods. Massive stars burn brighter and hotter but live shorter lives. They consume their nuclear fuel at a much faster rate, leading to a more rapid progression through their life stages. Smaller stars, on the other hand, conserve their fuel, shining dimly for billions and billions of years. These stars, often referred to as red dwarfs, can have lifespans that extend far beyond the current age of the universe. Understanding the main sequence stage is essential for astronomers as it provides insights into the past, present, and future of stars. By studying stars at different points in their main sequence, scientists can piece together the intricate puzzle of stellar evolution. Star clusters, which contain stars of various ages and masses, serve as natural laboratories for studying these processes. Observing these clusters helps scientists refine their models of how stars evolve over time. Our Milky Way galaxy is home to billions of stars, each at different stages of their life cycle. The main sequence stage is just one chapter in the fascinating story of stellar evolution, a story that continues to unfold with each new discovery. Eventually, every star runs out of hydrogen fuel in its core. When this happens, the outward pressure from nuclear fusion decreases. Gravity takes over, and the core begins to contract. As the core contracts, it heats up, and this heat causes the star's outer layers to expand outward. The star swells in size, becoming a red giant. Red giants are much cooler than main sequence stars, which is why they appear red. They are also much larger, often engulfing their innermost planets. In the core of a red giant, helium atoms begin to fuse, forming heavier elements like carbon and oxygen. Section 5: Stellar Endings, from white dwarfs to black holes. The fate of a star depends on its mass. Smaller stars, like our Sun, will eventually shed their outer layers into space, forming beautiful clouds of gas and dust called planetary nebulae. The remaining core of the star, now a white dwarf, will slowly cool over billions of years. Massive stars, however, face a much more dramatic end. They continue to fuse heavier and heavier elements in their cores, creating elements like neon, magnesium, silicon, and iron. Section 6: Supernovae, the spectacular deaths of massive stars. Iron is the end of the line for nuclear fusion. When a massive star tries to fuse iron, it requires more energy than it releases. This disrupts the delicate balance between gravity and nuclear fusion. The core collapses in on itself, triggering a catastrophic explosion called a supernova. Supernova are among the most energetic events in the universe, briefly outshining entire galaxies. They scatter the elements forged in the star's core across space, seeding new generations of stars and planets. Section 7: Neutron stars, the leftovers of supernovae. After a supernova, the core of the star is compressed to incredible densities. If the core is massive enough, it will collapse into a neutron star. These incredibly dense objects are only a few miles across, but they can have more mass than our Sun. A teaspoonful of neutron star material would weigh billions of tons on Earth. Some neutron stars rotate rapidly, emitting beams of radiation that sweep across space like cosmic lighthouses. We call these pulsars. Section 8: Black holes, the ultimate cosmic mystery. If the core of a collapsing star is even more massive, it can collapse beyond the point of a neutron star. It forms a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. Black holes are still shrouded in mystery, but we know they play a crucial role in the evolution of galaxies, often lurking at their centers. Section 9: Stellar alchemy, forging the elements of life. Stars are more than just points of light in the night sky. They are cosmic factories, forging the elements that make up everything around us. The carbon in our bodies, the oxygen we breathe, the iron in our blood, all were created in the hearts of stars. As Carl Sagan famously said, "We are star stuff." The atoms in our bodies were once part of stars that lived and died long ago. Section 10: The cosmic web, stars and the structure of the universe. Stars don't exist in isolation. They are bound together by gravity, forming vast galaxies that stretch across unimaginable distances. These galaxies are connected in a vast cosmic web, with clusters of galaxies forming the nodes of this web. Stars play a crucial role in shaping the structure of the universe. Their gravity helps to sculpt galaxies, and their light illuminates the cosmos. Section 11. Conclusion. Our place in the cosmic ballet. The life cycle of stars is a story of birth, life, death, and rebirth. It's a story that reminds us of the interconnectedness of everything in the universe. From the smallest atom to the largest galaxy, we are all part of this grand cosmic ballet. The next time you look up at the stars, remember that you are looking at the building blocks of the universe. You are looking at the past, present, and future of the cosmos, and you are looking at a reflection of ourselves, for we too are made of star stuff.